Good morning to all. In today's class, we will discuss interfaces. So, interface concept is very important in Java. Already I explained, we have three containers in Java. They are concrete classes, abstract classes, and interfaces. Okay. So, already till now we have covered concrete classes and abstract classes. The third container in Java is interface. This is very important in Java. So we have only three containers in Java. They are concrete classes, abstract classes, and interfaces. You know about concrete classes and abstract classes. Now we will see what is an interface, how to write an interface, and how to implement an interface. These three are very important regarding interfaces. So what is the purpose of writing interfaces? Then how to write the interface, that is the syntax for writing interface, and after writing the interface, how do we implement that interface? Okay, now we will see first what is an interface. Okay, so here the interface consists of only final variables and abstract methods. Okay, so interface consists of only final variables and abstract methods. First we will see what is final variable and what is abstract method. After that we will write interface programs. So because interface consists of only final variables and abstract methods, that's it. So already explained about final variables and abstract methods. First we will revise again these two concepts, that is final variables and abstract methods. After that we will see interfaces. Okay, why do we discuss these two concepts, final variables and abstract methods? Is because interface consists of only final variables and abstract methods. Okay, that's why first we will revise final variables and abstract methods. So already explained in the last class this abstract methods. So in Java, methods are of two types. They are concrete methods and abstract methods. So we will see the difference between these two types of methods. Already explained. Now I am revising these two concepts once again. Because unless you understand abstract method concept, you can't follow interfaces. Okay, that's why first we will see the difference between concrete methods and abstract methods. So what is concrete method? Okay, and how do we write the syntax for concrete method? Here M1 is called concrete method. Why? Because it is having body. Okay, these are the two important points to remember with respect to concrete methods. They are concrete methods should have method body, and another one is should not be declared with abstract keyword. If you see this method, we can say it is concrete method. Why? Because here it is having method body and it is not declared with abstract keyword. So that's why we can say this method M1 is concrete method. Okay, follow carefully. So in Java we can write two types of methods, concrete methods and abstract methods. So concrete, how do we identify the concrete method? Is concrete methods must have method body. Body means open brace and closing brace. Inside this body part we will write the functionality of that method. Okay, so here if you see M1 is the name of the method and it is having return type void and it is no parameters, means it is not taking any parameters. Okay, so here M1 is a method name. So here if you see this M1 method, it is having method body and it is not declared with abstract keyword. That's why with these 2 points we can say this M1 method is called concrete method. Next, when you see this abstract methods do not have method body and should be declared with abstract keyword, and the third point is ends with a semicolon. So with these 3 points we can say the method is abstract method. Now Here if you see this method, this M1 method is an abstract method. Why? Because first point is abstract methods do not have a method body. Here if you see this M1 method, it is not having method body like this. Body means open brace, closing brace. So it is not having method body. That is the first point. Second point, it must be declared with abstract keyword. Yes, it is declared with abstract keyword. And the third point, ends with semicolon. Yes, here this function ends with semicolon. So with these 3 points, we can say this M1 method is abstract method. Again, I am repeating abstract method definition because in interfaces we will use only abstract methods. We won't use concrete methods. That's why unless you understand abstract method concept, you can't follow interfaces. So try to understand the abstract method more clearly. So when you want to check whether the method is concrete method or abstract method, in case of concrete methods, we should remember these 2 points. In case of abstract methods, we have to remember these 3 points. Okay, now our focus is only on abstract methods in interfaces. That's why again I will explain this. Here, why do we say this M1 is abstract method is because M1 is the name of the method and it is not having method body and it is declared with abstract keyword and it ends with semicolon. So with these 3 points, I can say the method M1 is called abstract method. In the same way, M2 is also called abstract method. Okay. So here M2 is declared with abstract keyword and no method body and ends with semicolon. Okay. Return type can be any return type and it can take with parameters or without parameters. We can declare this method. This is the method syntax now. Every method has method name and return type and inside this parenthesis, here we can use parameters or no parameters means only simply write open parenthesis, closing parenthesis. This is already you know the method syntax now. This is the method syntax. Methods must have return type and with or without parameters. Okay. So for this method, I am using no method body and declared with abstract keyword and ends with semicolon. So in this case, this method M1, M2 is also said to be abstract method. So here we can see M1 and M2 are abstract methods. In this case, M1 is called concrete method. First, we should distinguish concrete methods and abstract methods. Okay, once you understand this abstract method, see already explained now. Okay, we have 3 containers. They are concrete classes, abstract classes and interfaces. We have covered till now concrete classes and abstract classes. Now we are going to discuss interfaces. Okay, now here I will explain abstract class also before going to discuss interface. Now here we have 3 concepts now: concrete classes, abstract classes and interfaces. This is the 3rd container. These are the 3 containers: concrete classes, abstract classes and interfaces. Okay, so we know concrete classes and abstract classes. Now we will discuss interfaces. But to understand interfaces, we need to understand what is the difference between concrete classes and abstract classes. Then why do we need interfaces? Okay, in the same order follow. First study concrete classes, then abstract classes, then interfaces. Now first I will revise the concrete classes and abstract classes, then I will start interfaces. Okay. So what is the difference between concrete classes and abstract classes? Already I explained the difference between concrete methods and abstract methods. Now try to understand the difference between concrete classes and abstract classes with respect to concrete methods and abstract methods. In the same order you follow, then you can easily understand. Now we will see what is concrete class, then we will see what is abstract class. So now already we understood that the difference between concrete methods and abstract methods. So with respect to these 2 types of methods, we will differentiate concrete classes and abstract classes. So what is the difference? So what is a concrete class? See, concrete classes must contain only concrete methods. See, concrete classes must contain only concrete methods and should not be declared with abstract keyword. So with these 2 points, I can say the class is concrete class. And now we will see concrete class. Now I can say here, A is concrete class. There is no keyword like concrete. Okay, class means concrete class. Don't say concrete class. But for your understanding, I am explaining with respect to concrete class and abstract class. Actually, there is no concrete keyword. Only class is nothing but concrete class. Okay. Now here we say A is concrete class because we know the syntax for class. Class name. Okay. Open brace, closing brace. Inside this class, we can write variables and methods. Okay. Now here I have written 2 methods, M1 and M2. First, identify whether they are concrete methods or abstract methods. Now you know the difference between concrete methods and abstract methods, no? As per that concept, I can say here M1 and M2 are concrete methods because these 2 methods are having method body and not declared with abstract keyword. So I can say M1 and M2 are concrete methods. So here this is the class A. Now I have to say whether class A is concrete class or not. How do I say is concrete classes must contain only concrete methods and should not be declared with abstract keyword. Now I will check these 2 points with respect to this class A. First point is must contain only concrete methods. Here class A contains only concrete methods. They are M1 and M2. Next after that, this class A is not declared with abstract keyword. So with these 2 points, I can say class A is concrete class. Now coming to the abstract class. Okay, so abstract classes may contain only concrete methods and only abstract methods or both concrete and abstract methods. This is first point. And second point is the class must be declared with abstract keyword. Okay, so again I will repeat the first point is abstract classes may contain only concrete methods or only abstract methods or both concrete and abstract methods. That is the first point to remember with respect to abstract classes. And the second point is the class must be declared with abstract keyword. This is must. So with these 2 points, I can say whether the class is abstract class or not. Now I will explain. Here, this is class A, class name. This class is declared with abstract keyword and it consists of only concrete methods. It is correct only, no? Because with this first point, abstract classes may contain only concrete methods, only abstract methods, or both concrete and abstract methods. All the 3 are correct. But concrete classes must contain only concrete methods. Understand the difference between the first point in these 2. Here it consists of only concrete, only abstract, or both concrete and abstract, and the class must be declared with abstract keyword. Now if you see this class A, we can say A is abstract class because it consists of only concrete methods. Yes, correct. And it is declared with abstract keyword. Second point is also true. That's why we can say this class A is called abstract class. Okay. Next. Now we have seen the difference between concrete classes and abstract classes. After that, how do we write the abstract classes? Okay. Then we will see. Okay, who will implement the, or otherwise I can show you one more abstract class. After that, we will see the points. Already explained these 2 programs, so only I am revising. If you see this, okay, I will explain one more abstract class. Here in the previous abstract class, it consists of only concrete methods, no? But if you see this abstract class, okay, this class is declared with abstract keyword, and this class A consists of 1 concrete method and 2 abstract methods. Already explained the first point in abstract classes, no? That is, abstract classes may contain only concrete methods, only abstract methods, or both. Here, it consists of both concrete method and abstract methods. Here, if you see, M1 is concrete method and M2 and M3 are abstract methods. So here, and A is declared with abstract keyword. So with these 2 points, I can say the class A is abstract class. So this is the syntax of writing abstract class. Abstract class may contain only concrete methods, only abstract methods, or both. Here this class consists of both concrete and abstract methods. So the and declared with abstract keyword. So I can say A is abstract method, abstract class. Now here you may get one doubt. So in abstract classes we are writing abstract methods. Abstract methods do not have method body. So who will implement these abstract methods in case of abstract classes? Here that is the question you may get here. So who will implement the abstract methods of the abstract class? Is the answer for that question is there must be one class, okay, which extends that abstract class. This is must for abstract classes. So after writing the abstract class, there must be one class which extends that abstract class, and the role of this class is to provide the implementations to all the abstract methods of that abstract class. So here you see the syntax, class B extends A. You know A is abstract class. So that's why here B will provide the implementations to these two abstract methods, that is M2 and M3. Okay. So if you observe this class B, it is providing the implementations for M2. This is the implementation of M2 and also for M3. Why? Because M2 and M3 are declared as abstract methods in class A. That's why when this class extends the abstract class, the role of this class is it has to provide the implementations to all the abstract methods of the abstract class. Here already explained, inside the abstract class here I have two abstract methods. They are M2 and M3. M1 is concrete method. It has already body. So here these two methods do not have method body. Who will implement these two methods? Is a class. There must be one class which extends the abstract class, and that class must provide the implementations to these two abstract methods, that is M2 and M3. So if you observe class B, it is providing the implementations for both the methods, that is M2 and M3. After that it can write its own methods. Here M4 is the own method to class B. Okay. Now here A is abstract class. Okay. When you write abstract class, there must be one subclass which extends that abstract class. This is inheritance. So whenever you use abstract classes concept, we must use inheritance. There is no other alternate. You can write any number of abstract classes in a program, but after writing the abstract classes, okay, there must be subclasses for abstract classes. See here if you observe, A is abstract class and B is the subclass, or B is a class which extends this abstract class. That's why whenever you write abstract classes programs, always we need to use inheritance concept. Already explained inheritance programs in depth. So in inheritance, class B is called subclass, A is called superclass. So what is the purpose of this subclass is we have to apply code reusability in inheritance. Means inside the subclass, no need to write the code of the superclass. Okay, without writing the code, okay, of superclass, it can use that code by using this extends keyword. The advantage of inheritance is code reusability. Once you write the code in class A, there is no need to write the same code inside class B. Automatically, when you use extends keyword, the code which is there inside class A is inherited to this class B. In addition to that inherited code, the class B can write its own code. Okay. So without writing the code of class A, directly the class B can use the code of class A using extends keyword. Okay. Inheritance is very, very important. And now here, this is the abstract class concept. So first write abstract class, and after writing there is no use of this single class. Okay. When you write abstract class, you must write this one. There must be one class which extends that abstract class. Okay. The purpose of this class is it will implement the abstract methods of that abstract class. Okay. Next, this is the next. How do we create reference variables and objects to abstract classes? Because here we have two classes. Class A is abstract class and class B is concrete class. So with respect to reference variables and objects, remember these 2 points. For concrete classes, we can create objects, but for abstract classes, we can't create objects. For abstract classes, we can only create reference variables. Okay. So here, when you create reference variables for abstract classes, you can't access the members of the abstract class. That's why in abstract classes, we should use upcasting. Already explained upcasting. Upcasting is nothing but subclass object is assigned to superclass reference variable. Here, which one is superclass? A is superclass and B is subclass. So, with respect to these two classes, I can explain upcasting. Upcasting is nothing but subclass object is assigned to superclass reference variable. With this reference variable, I can access all the members of the superclass except overridden methods. Already we have written programs using upcasting. Now revise once and understand these abstract classes. See, because the same concepts we will use in interfaces. If you understand here, then there in interfaces we use the same concepts. That's why whenever you write abstract classes, okay, whenever you write abstract classes, there must be one class which extends that abstract class, and this class of this is subclass, this is superclass. This class B must provide implementations to all the abstract methods of the abstract class. That is the first point. After that, for abstract classes, we can't create objects. We can only create reference variables. Okay. So without creating objects for abstract classes, we can't access the members of the abstract classes. That's why what we have to do is, we have to use upcasting. So without creating objects for abstract classes, how do we access the members of the abstract classes? That is the question now. So the answer for that question is, using upcasting, we can access the members of the abstract classes. So what is upcasting is, subclass object is assigned to superclass reference variable. With that reference variable, I can access all the members of the abstract classes. Okay. So here B is called subclass, A is called superclass. And you know B is concrete class, because B is not declared with the abstract keyword. And another point is, it consists of only concrete methods. So I can say B is called concrete class, and for concrete classes we can create objects. See, understand the difference, one more difference between concrete classes and abstract classes. For concrete classes we can create objects, but for abstract classes we can't create objects. We can only create reference variables. That's why with respect to these two classes, we have to use upcasting to access the members of the abstract classes. Now I will explain that concept. Now the next question is, how do we access the members of the abstract classes without creating the objects for abstract classes? So the answer for that I will explain here. Now I have taken one more class. In that I have written main method. In that I want to access the members of the abstract class. You know, A is abstract class and B is concrete class, which is a subclass to this superclass A. A is superclass and B is subclass. And A is abstract class, B is concrete class. For concrete classes, we can create objects. So I have created object for the concrete class B, which is a subclass of A. So new B is the object for class B, and subclass object is assigned to superclass reference variable. Here A is called abstract class. So with this reference variable A1, I can access all the members of the abstract class A except overridden methods. Okay. So if I write A1.M1, all the members of class A, no? With this reference variable, I can access all the members of the abstract class A. So how many members are there in abstract class A? 3 members, that is M1, M2 and M3. So with that reference variable, I can access only the members of class A except overridden methods. In case of overridden methods, subclass overriding methods will be executed. If you see this abstract class here, these two are overridden methods. M2 and M3 are called overridden methods. So in case of overridden methods, with upcasting, subclass overriding methods will be executed. Means with that upcasting reference variable, M1 method of class A is executed, and in case of overridden methods, subclass overridden methods M2 and M3 are executed. And one more point is, with that reference variable, we can access only the members of class A. What are the members of class A? M1, M2 and M3. Now here the question is, can you access the M4 method of class B? No. Why? Because already explained upcasting in depth. So this is upcasting. Subclass object is assigned to superclass reference variable. With this reference variable, we can access only the members of class A. So here we have 3 members inside class A. They are M1, M2 and M3. So with this reference variable, I can access only the members of class A, that is M1, M2, M3. I can't access the members of class B. Okay. So that's why I can access only A1.M1, A1.M2, A1.M3. But what will be the output for these 3 statements is, M1 method of class A is executed, whereas in case of overridden methods, the subclass methods are executed. That is, in case of M2 and M3, these methods are executed. That's why the output is here. This is A's M1 method in these 2 statements, B's M2 method and B's M3 method. Again, I am repeating the statement, upcasting. So upcasting is nothing but subclass object is assigned to superclass reference variable. With that reference variable, I can access all the members of the superclass except overridden methods. Understand the point? Except overridden methods. In case of overridden methods, subclass overriding methods will be executed. That's why here M2 and M3 of class A are called overridden methods. So that's why in case of M2 and M3, subclass, that is B's class overriding methods will be executed. That's why in these 2 statements, the output will be B's M2 method and B's M3 method. But here A's M1 method. Okay. Suppose if you want to access M4 method, which is there in class B. Okay, with A1, if you are trying to access M4 method of class B like using A1.M4, you will get compiler error. Because what is upcasting is, with this reference variable, we can access only the members of class A. If you observe, M4 is not a member of class A. It is a member of class B. That's why I can't access with this reference variable M4 method of class B. That's why if you try to access M4 method of class B using A1, you will get compiler error. So this is abstract class. Okay. This is the syntax for accessing abstract class members. How do we access the abstract class members is, directly we cannot create objects for abstract classes, but already explained, whenever you write abstract classes, compulsory we should write one subclass. This is abstract class now. Whenever you write abstract class, compulsory there must be one subclass which extends that abstract class, and this subclass must provide implementations to all the abstract methods of the abstract class. After that, how do we access the members of the abstract class is using upcasting. So upcasting is nothing but subclass object is assigned to superclass reference variable. With this reference variable, we can access all the members of the superclass except overridden methods. In case of overridden methods, subclass overriding methods will be executed. That's it. If you understand these 3 points, enough for abstract classes. Okay, what is the first point? First, create abstract class like this. This abstract class consists of concrete methods and abstract methods. After that, the second point is there must be one subclass which extends abstract class, and that subclass will provide implementations to all the abstract methods of the abstract class. Okay, M2 and M3 are the abstract methods inside the abstract class. So the subclass is providing the implementations to these two abstract methods. After that, the subclass can write its own methods, that is M4. Okay, this is second point to remember. Third point is how do we access the members of the abstract class is, I will take one more class, inside that I will write my main method. So for abstract classes, we can't create objects like A1 is equal to new A. UA is not possible. Means for abstract classes, we can't create objects. That is A1 is equal to new A. If you write it, you will get compiler error because new A is nothing but object of class A. It is not possible in case of abstract classes. That's why we can't create objects for abstract classes. We can only create reference variables for abstract classes. So with this, it is not possible to create objects for abstract classes. No. So what is the other way to access the members of abstract class is using upcasting. So how do I access the members of the abstract class A is using this syntax. So what is the syntax is, subclass object is assigned to superclass reference variable. With this reference variable, we can access all the members of the superclass, that is abstract class. Okay, same concept we will apply for interfaces also. If you understand the abstract classes concept, it is very easy to understand interfaces. That's why try to understand the abstract classes. Okay, first create abstract class, then second is they create one subclass which extends that abstract class, and third point is create reference variable for abstract class and assign subclass object to that reference variable, and using this reference variable we can access the members of the abstract class. And here we have to using upcasting concept. Upcasting is nothing but subclass object is assigned to superclass reference variable. With that reference variable, we can access all the members of the superclass except overridden methods. In case of overridden methods, subclass overriding methods will be executed. If you understand all these points for these abstract classes, it is very easy to understand interfaces. Okay, that's why I am revising abstract classes once again. If you take this one, this is like a subclass object only, no? Here there is no concept. If you write also no use. If you want to create subclass object, create object, and with that object we can access all the superclass and subclass members. Here M1 and M2, M1, M2 and M3 are superclass members, and M4 is subclass member. So with the subclass object I can access all the members of the superclass and subclass. Okay, so here this is the important concept. Okay, first create reference variable for abstract class and assign subclass object to that reference variable. With this reference variable, we can access all the members of the abstract class, that is A. Okay, so this is for abstract classes. Okay, once you understand this concrete classes, abstract classes, then we will go to these interfaces. Okay, already explained abstract classes in depth. Listen that video and try to write more number of programs for abstract classes. Now, what are the three containers in Java? Concrete classes, first one. Second one is abstract classes. Third one is interfaces. Okay, now we will discuss interfaces. And one more point to remember is final variables. Okay, what is the difference between non-final variables and final variables? Already explained final keyword with respect to three concepts: final variables, final methods, and final classes. Okay, explain in the exam. Explain the final keyword with examples means we have to explain three concepts with respect to final keyword. They are final variables, final methods, final classes. So what are final variables and what is the difference between final and non-final variables? Final variables cannot be modified. Means if you declare a variable with final keyword, then that variable cannot be modified throughout that program. Means final variables are treated like constants. Okay, non-final means you can modify the non-final variable. Non-final variable means a variable which is not declared with final keyword. So here in interfaces we should remember 2 points: final variables and abstract methods. These two are very, very important with respect to interfaces. So first we need to understand what are final variables and what are abstract methods. Once you understand final variables and abstract methods, it is very, very easy to understand interfaces. Okay. Now what is final variable? Final variables cannot be modified throughout the program. Means once a variable is declared with final keyword, okay, then if you assign a value to that final variable, that value is used throughout that program. You can't modify the final variables. That is the final variable concept. Already explained abstract method. So with respect to these two concepts, that is final variable and abstract method, we will discuss interfaces. Okay, this is the third container in Java. Very, very important concept. So what is interfaces? What are interfaces? Interfaces contain 100% abstract methods. Okay, and one more point is interfaces consists of final variables and abstract methods. Okay, now here the question is, what is the difference between abstract classes and interfaces? Okay, already explained. Abstract classes may contain only concrete methods or only abstract methods or combination of concrete methods and abstract methods. But if you take interfaces consists of only abstract methods. Okay, in interfaces we can't write concrete methods. That's why interfaces contain 100% abstract methods. That is the important point to remember. And one more important point is interfaces contain both final variables and abstract methods. If you want to write variables in interfaces, we must write only final variables and only abstract methods. That's why here the thumb rule is interfaces consists of only final variables and abstract methods. If you understand this statement, it is very, very easy to write interfaces. Okay. Now first we will, before going to discuss interfaces programs, first we will try to understand the differences between concrete classes, abstract classes and interfaces, because these are the three containers which are used in Java. What are the three containers in Java? Concrete classes, abstract classes and interfaces. First we will see the differences between these three containers. After that we will write the programs on interfaces. Now what is so here we will see the differences between these three containers with respect to variables and with respect to methods. Because in any class we will write only variables and methods now. Already in the first class itself I explained class definition. Class consists of only state part and behavior part. State part is nothing but variables, behavior part is nothing but methods. That's why if you take any class, it consists of only variables and methods. That's why here if you take concrete class or abstract class or interface, okay, so these three contain only variables and methods. Okay, that's why how to discuss the differences between these three types of containers is with respect to variables and methods. And understand carefully. Now I will explain first with respect to methods. Means which types of methods are used in concrete classes, in abstract classes and interfaces. Next, similarly, which types of variables are used in concrete classes, in abstract classes and interfaces. If you understand this table, then you can easily understand the differences between concrete classes, abstract classes and interfaces. Okay. Now Here, if you take concrete classes, there is no keyword concrete. Okay. If you take concrete classes, it consists of only concrete methods. Already explained. Okay. Concrete classes consists of only concrete methods. If you take abstract classes consists of only concrete methods, or only abstract methods, or both concrete and abstract methods. Next, if you take interfaces, interface consists of only abstract methods. You can't write concrete methods in interfaces. In the same way, you can't write abstract methods in concrete classes. So understand these 3 points. So in concrete classes, we can write only concrete methods. In interfaces, we can write only abstract methods. But in abstract classes, we can write both concrete methods and abstract methods. That is the first difference with respect to methods. Now, what is the second difference with respect to variables is, see, concrete classes consist of both final and non-final variables. Final variable means if a variable which is declared with final keyword. Non-final means if a variable which is not declared with final keyword. Okay. Next, concrete classes consists of both final and non-final variables. Abstract classes also consists of both final and non-final variables. But if you take interfaces, interfaces consist of only final variables. Okay, so this is the second difference with respect to variables. If you understand, now we will discuss only interfaces in today's class. Now focus on interfaces. Already I have covered concrete classes and abstract classes in depth in the previous classes. Okay, only but for revision I am explaining till now these two, concrete classes and abstract classes, because if you understand these two classes, then only you can understand interfaces. That's why I have revised these two classes once again. Otherwise, I have explained all the concepts with respect to concrete classes and abstract classes in depth. Please go through the previous videos and try to understand concrete classes and abstract classes in depth. Now we will discuss interfaces. If you see the last column, this is the definition of interface. So from this last column, what we can say, interfaces consist of only abstract methods and final variables. That is the definition of interfaces. So interfaces consist of only final variables and abstract methods. You know the definition of final variables. Final variables cannot be modified. Okay, once you assign the value for the final variable, we can't change that value throughout that program. That is the final variable concept. So interface consists of only final variables and abstract methods. Okay. Now we will see how to write the interface. Now we will see the syntax for interface. And already I hear the same sentence I have written. Interfaces contain final variables and abstract methods. You remember these 2 points. Next, what is the syntax for interfaces? So interface name, like class name. Here we have interface name. Interface is a keyword and interface name is an identifier. You know the rules for writing identifiers. Okay. Next, open brace, closing brace. Interface is like class only. So inside this open brace and closing brace, we will write only final variables and abstract methods. So this is the syntax of interface. So interface consists of only final variables and abstract methods. And how do we write the interface is interface name. Interface is a keyword, interface name is an identifier. Okay, like a class definition only. This is interface definition. Now I will show you the examples. So interface, all lowercase letters, and I1, name of the interface. Okay, inside the interface here, this closing brace is missed. Put the closing brace here corresponding to this open brace. So inside the interface, I have written only final variables and abstract methods. Here, what are the final variables? Two final variables are there. They are A and B. Okay, so A is assigned with 10 and B is assigned with 20. Okay, so these two are final variables. And what is the final abstract method? M1 is abstract method. So if you take this interface I1, it consists of two final variables A and B and one final method M1, not final method, one abstract method M1. Already explained, interface consists of only final variables and abstract methods. Okay, this is here we have to put closing brace. So this is the interface example, because this interface consists of only final variables and abstract methods. So what are the two final variables? A and B are final variables. And what is the abstract method? M1. Now you can identify the abstract method syntax. No method body and declared with abstract keyword and ends with semicolon. How to identify final variables? A and B are variables which are of integer data type and are declared with final keyword. That's why we can say A and B are final variables. Once you assign the values for final variables, they cannot be modified throughout the program. So interface, this is the interface which consists of final variables and abstract method. Okay, two final variables and abstract method. And now with respect to interface, we have to remember the default ones. By default, see, here we have to remember three important points. By default, all the variables of the interface are public, static and final. Already explained static keyword also. Static variables also explained in the last class. Okay. Now by default, all the variables of the interface are public, static and final. By default means whether you write or not, the compiler will add these three keywords for variables. What are the three keywords? Public, static, then final. Next. By default, all the methods of the interface are public and abstract. Public and abstract. Okay. Next. What is the third rule is the access modifier of the interface is default. Already explained there are four. We have four access modifiers. They are private, okay, default, protected and public. Okay. So here the access modifier of the interface is default. There is no keyword for default. If you won't write anything, okay, the compiler will take default. Now I will show you. So interface I1. Suppose if you write only int a is equal to 10 and b is equal to 20. I am writing only int a is equal to 10 and b is equal to 20 inside the interface I1. So if you won't write anything here, what the compiler will add is, the compiler will add for this statement these three keywords. They are public, static, final. By default, these three will be added by the compiler. So no need to write these three keywords. If you write also wrong. If you write all the three also correct, or if you write only two also correct. If you write only one also right. Okay. If you won't write also correct. If you won't write any keyword, okay, then what the compiler will do is, compiler will add for these two variables public, static and final. Public, static, final. These three keywords will be added by the compiler at the compilation time for these two variables. That's why we are saying this is by default. No need to write. Actually, if you write this statement, enough. By int a is equal to 10, b is equal to 10. If you write, the compiler will add these three. If you write also correct. If you write one also correct, two also correct, all the three also correct. If you won't write anything also correct. Okay. Next, coming to the methods. So if you write only void m1 also correct. So if you write only void m1, the compiler will add public, abstract. These two keywords are added to all the methods of the interface by the compiler. They are public and abstract. So for the variables, the compiler will add public, static, final, and for the methods, compiler will add public, abstract. If you write also correct. Abstract must know here, because all the methods in the interface are abstract and all the variables in the interface are final. Okay, in addition to final and abstract, it will add for variables public and static. Here for methods, it will add public. Public is the access modifier. If you write public means anybody can use. Okay, I will explain in depth about the access modifier later. Now understand public variables and methods can be used outside the class or outside the package also. Okay. Next. So here what is so first point is all the interface variables are public, static, final, and all the interface methods are public and abstract by default. Now coming to the interface. Okay. For this the compiler will add default. Okay. Already it is default only. Now if you won't write any access modifier to the interface, it is default. Here The access modifier of the interface is default by default. But if you want to write the access modifier for the interface, we can write only public explicitly. Why? Because here we have 4 access modifiers. They are private, okay, default, protected, and public. But okay, for interfaces by default access modifier is available. But if you want to write explicitly for the interface, we can write only one modifier, that is public. You can't use default and public for the interfaces. Suppose here this is interface, no? So suppose if you write here protected, you will get compiler error. Or if you write here private, you will get compiler error. Only one modifier explicitly I can write here is public. That's it. If you won't write anything, default access modifier is available. Okay. So these are the 3 points to remember. We have to remember with respect to interfaces. Okay. In all the interface variables are public static final by default, and all the interface methods are public abstract by default, and the interface access modifier is default by default. But if you want to write explicitly, we can use only public access modifier. We can't use private and protected access modifiers for the interface. If you use private and protected access modifiers for the interface, you will get compiler error. That's it. If you understand this interface concept, it is very easy to write the interface programs. Okay. Here only 2 access modifiers can be used for interfaces. They are default and public. That's why we can't use the other 2 access modifiers, that is private and protected, because we have only 4 access modifiers in Java. Okay. Next. Now is it the valid syntax for interface? Yes or no? Okay. Now I will check. So here these 2 are interface variables. We can simply write like this. If you write like this, then the compiler will add for these 2 variables public static final. Okay. Next, when you write like this simply, the compiler will add public abstract, because it is method. For methods it will add public abstract, and for variables it will add public static final. Yes. Next, here in the previous, the difference between the previous syntax and this syntax is, here I have not used any access modifier for this interface. When you won't use by default, it will add default access modifier. But if you want to use explicitly the access modifier, we can use only public, because we can't use private and protected. That's why this is correct syntax. If you want to use access modifier for this interface, we can use only one explicitly, that is public. That's why public interface I1 this. Okay, these variables are by default public static final. This method is by default public abstract. So this is the correct syntax for interface. Okay. So after defining the interface, again it is like abstract class only, no? So inside the interface we have abstract methods only, no? But by default this method is public and abstract, no? Means this is abstract method. So abstract methods must be implemented, no? Who will provide the implementation for this abstract method in case of abstract classes is, there must be one subclass which must extend that abstract class, and that subclass must provide implementation to the abstract method. Now that is in case of abstract classes. But in case of interfaces, who will provide the implementation for this abstract method M1 is, there must be one class which must implement this interface, not extends. Here implements. So in case of abstract classes, there must be one subclass which extends abstract class now. But in case of interfaces, there must be one class which implements this interface. That's why in case of interfaces, we use the keyword implements, not extends. Again, understand one more difference between abstract classes and interfaces. In abstract classes, there must be one subclass which extends that abstract class. But whereas in interfaces, there must be one class which implements that interface. That is the one more difference between abstract classes and interfaces. Try to correlate these two, abstract classes and interfaces. Then only you can understand the concepts. Don't study independently the interfaces. Okay, compare the interfaces with abstract classes. Okay, then study the interfaces. Then it is easy to remember and it is the correct way of studying the interfaces. First, the sequence is first study concrete classes thoroughly, then after that abstract classes thoroughly, then interfaces thoroughly. In this sequence only we have to study concrete classes, abstract classes, interfaces. Now what is after defining the interface? This is the definition of the interface. After defining the interface, there must be one implementing class which implements this interface, and the purpose of that implementing class is it has to provide the implementations to all the abstract methods of that interface, like abstract classes only, but only syntactically some differences are there, otherwise concept is same. So after defining the interface, there must be at least one class which implements that interface, and that class has to provide the implementations to all the abstract methods of that interface, right? Then that class can be called implementing class. Only for our understanding, we are calling that class as implementing class. Now here, I have defined interface like this. Now interface, S is not there. Interface, name of the interface, and here this is the body of the interface. This is called the interface definition. So after defining the interface, here I am taking what is the syntax to implement this interface. Class A implements I1. Here this is the class A definition. Okay. Next, similarly, once you define interface, okay, there can be any number of implementing classes which implements this interface, same interface. So here if you see this diagram, you can understand. So I1 is the interface. First define the interface. After that write one class which implements that interface. The syntax is class A implements I1. What is the role of this class A is, inside this class A definition, it has to provide implementations to all the abstract methods of that interface. Next, I am taking one more class which implements this interface. Again, this class also has to give implementations to all the abstract methods of that interface. Okay, like that, there is one more class which implements I1. Like that, once you define the interface, we can have any number of classes which implements that interface, and the role of these three classes is to provide the implementations to all the abstract methods of this interface. Here you may get one doubt. Why these many classes? One class is enough, no, to implement this interface. Means what is the advantage of taking more number of classes which implements this interface is, A can provide implementations to all the abstract methods of this interface in its own way. Next, when B implements this I1, B can provide the implementations to all the abstract methods in its own way. Like that, these three classes can provide implementations to the abstract methods of this I1 in their own way. Okay, here it will provide the implementations in its own way. This class will provide implementations in its own way. Okay, so that's why once you define the interface, we can have any number of classes which implements that interface, and all these classes can provide implementations to all the abstract methods of this interface in their own way. Okay, so that's why here what is the syntax for implementing this interface is, class A implements I1, and this class A, inside the class A definition, it will provide the implementations to all the abstract methods of this interface. Similarly, class B provides the implementations to all the abstract methods of this I1. Okay, this is the syntax of interface, and this is the syntax of the classes which implements that interface I1. Okay, now here we will stop. Next class we will see how to write the interface programs.